Okay, recording is going. I sent out the HackMD URL. Hopefully you all have it. I want to say welcome to Florian and Sabri and any other non-typical participants, Jack Greenbaum, I guess. And I don't know, Florian, do you want to kick off with a little introduction to your thinking? There's also the document that you sent out, which I think some people have read, hopefully. Would that be helpful? Would you like to do that? Or are you not prepared for that?
I can do that. So first of all, thank you all for making time. Maybe Jack, you just want to quickly introduce yourself. So Jack is basically coming along as a guest from Safety Critical Industries to give a couple of inside opinions if needed. You're muted.
There we go. Okay. Yeah, I'm Senior Director of Engineering in the Green Hills Advanced Products team. And in our team, we work with a lot of safety critical customers in automotive, other areas of transportation, security critical folk, space flight applications even. So that's the industry that we come from. I have a background in compilers, EDA, and I've been at Green Hills for about 15 years. Felix, I think I joined just after you left.
Yeah, that sounds about right. Yeah, I left in 2002, I think.
Yeah, and I joined in 2003. So yeah, that's where I'm coming from. We've been doing some work with Florian and James and Sabri, looking at how Rust might fit into the type of applications that our customers build. Our main two products are our development tools, the multi-IDE and Green Hills C and C++ compiler. And then our runtime software, the Integrity Real-Time Operating System, which is safety certified, security certified, and in fact has achieved the highest security certification of any commercial RTOS. So that's the world we live in. Our customers are building safety and security critical applications, and we're interested in having Rust available there because of all the goodness that Rust brings with it. So that's our interest here.
Yeah. So I circled around the document before around making a proposal to think more about increasing trust levels of the Rust compiler at the core compiler itself. Called it the Rust specification verification proposal because I think both of these actions will be part of that plan. And wanted to give you a short introduction into our thinking. And our goal here is to make this conversation more public and bring it to a project level. We've done a lot of research over the last 1.5 years. We've been talking to you last year. James has been talking to you around our initiative there. And we've been looking at what the Rust compiler already brings or what is currently on the road and currently on track, and found a lot of things that we think are already useful there and can be what we can invest in and that we can maybe bring over the finishing line and add a couple of things on top. And we came up with basically a crucial core idea when we were talking to people who are already doing verification work on top of Rust. And the interesting thing that we figured out is that the focus tends to not be on the surface language, but rather on Mir. So a lot of consumers in that space, I would say, of our software stack actually focus on Mir. Was there a question? I heard a quick noise. Okay. And so that was, yeah, that's the quick summary of all this. Hi, Tim. Sorry for that. Tim is also from Green Hills and one of the people that have been speaking to us about that. Yeah. So we found out that most of the analysis and most of the safety critical tooling that's built on top of Rust is actually built on top of Mir, which was one of the most interesting findings that we had there. Are there any questions to that up until now?
So I missed the beginning. The invite had a Google link.
Sorry, I invited Daniel here to you're in the ARG. Are you in the automated reasoning group?
I'm not reasoning group, yeah.
Yeah, who's interested in hearing about some of the Mir developments and so on that we've been talking about. So I think there was a little confusion over the meeting URL.
Mute Josh again, please.
We're just getting started. We were talking about the kind of overall approach and the idea of working on critical safety critical systems and so forth. But I don't know. So we haven't done a lot yet. I think we were going to start going through the kind of some of the principles or talk about what we're trying to do, right?
Yeah, I first wanted to check if there's any questions on this part.
Am I right in inferring here that the Mir really is the core focus of what we'll be talking about? Or are there any other things that people think we also need to be thinking about? I'm not familiar with what the tooling is that, for example, what Green Hills is using for its validation of integrity anymore, since it was so long ago.
So that was not only discussions with Green Hills, but also, for example, if you look at what the GH Zurich is doing, that's mostly based on Mir. Like all the public research projects are actually centering around Mir. So when we're talking about verification, we found that we're mostly talking about verifying an already transformed Rust program to Mir. That was generally what we found. That does not mean that no one's looking at the language or, for example, language evolution. This is a little bit further down in the document that I wrote. Some more structured approach, for example, on the trait system, like Chalk is currently that is being currently being implemented with Chalk, or, for example, Polonius as a more rules-based a lifetime checker will probably help at specifying them for example, allowing other tools to use them and hook into that if you want to do any kind of things on that level.
And one thing that may be useful may also be like, I don't know how much already exists, but a contract language, right? Because one of the things that we're going to want as we do verification on Rust is a way to talk about the properties. So what are the invariants of the data structures? What does it mean for a data structure to be well-formed? What are the pre and post conditions of a function? And so that's something that we could, hack together with, calls to especially name functions or whatever. But if everyone agrees on a similar contract language, that's going to allow a lot of this work to be reused.
That's pretty specific to verification, right?
Well, not necessarily, because we found that verification, the contracts you make for verification also could be very useful for runtime checking and fuzzing. So ideally, in fact, you want a language where you have subsets that may be runtime checkable and subsets that may be verifiable, but you can get a lot of the benefit for both through the same language. Even if you sometimes lose some of the expressivity maybe you would get if you're able to talk about like, you know, a more powerful logical language, for example.
Would it be possible, without going into too much of a tangent on verification specifics, to give an example of the kind of verification step that is commonly done using Mir today? Like how it's expressed using Mir rather than using Rust as an example.
Yeah, I think the large sort of notion here is that Mir semantics are just far simpler than Rust's, and you know, and so if you're looking to create any sort of formal semantics, Mir sort of makes sense because everything reduces to Mir at some point, so that's sort of, I think, the larger thinking. But I also kind of wanted to go back to Daniel's point, which is a contract language is sort of in scope for a lot of around some of the things that we're working on, but isn't sort of the primary goal of this proposal,
Sure.
which is specifically around Mir and sort of Rust itself. Being able to make formal verification of Rust programs more ergonomic is definitely in scope for just our thinking and sort of the initiative that we're trying to launch off of the ground. But again, sort of out of scope for this.
I think the flavor I was trying to get at a high level is, are we talking about analyses of Mir with an eye towards proving some very specific property of a program, like this thing is within this range, for example?
Mm-hmm.
Or are you talking about trying to completely prove the behavior of a program, like the Mir precisely matches this specification and does absolutely nothing that isn't in this specification? Total proof or very narrow property proof or somewhere in between? That's the flavor I was looking for.
Yeah, I think the first step to a lot of that is just making sure that Mir itself is sound, right? And so, you know, are Mir semantics sound? Is it a base from which you can actually build proof? Because if Mir isn't sound, then you really can't.
I see. Okay.
Can't really
so
do that.
Formal
Based on
semantics
what we've
from Mir
done,
first, and then you can build to semantics of something written in Mir.
Correct.
Yeah.
Okay.
And based on what we've done sort of at AWS with C and what we're currently sort of looking to build similar capabilities for Rust, there's sort of both directions, right? So there's a lot of work where you want to say, like, does this program have undefined behavior? Right? So in Rust, for example, a program that has some unsafe code, can we, given the constraints on the inputs to this program, can we possibly have undefined behavior, right? And so you want to, for example, take the exact Mir semantics, put that into something like a model checker, and then have the model checker tell you whether undefined behavior states are reachable. And there's the other extreme, which is the stuff that we've done with, like, for example, some of our crypto code, where you want to say, like, is this bit for bit identical to the specification in the RFC, right? And so there, you're willing to invest a huge amount of human effort to prove that the only bits that can be emitted from this exactly match what you have in some formal specification. But there's a lot of code that sort of, you know, it really depends on the business case for the code, right? If you have code that you really care about the precision, like crypto, it's worth doing that. If you have code that's like, you know, handling some Lambda functions off the wire, maybe you want to prove it can't have UB, but if it does the wrong thing, well, it's part of a distributed system that expects some amount of errors.
So I want to try to focus I'm looking at the clock and thinking about our time, and it seems like this is good background and we should keep having this conversation, but I want to talk a little bit about, like, how I understood what we're trying to get out of this meeting is basically, we know we're not going to solve all the problems, certainly not in 45 remaining minutes, but what we can do is talk about what are the most important things to be talking about over the next period of time, and how do we want that to proceed, right? And I agree with Sabri that that if we want to enable these use cases, kind of what we need to be doing is coming up with some definition that we can work from of like what a Rust program means, and mirror is a good starting point. And sort of the components seem to be mirror traits, types, and maybe like layout. that's my usual list. Layout meaning like given a type, where does it appear in memory? And we could talk about like, is that the right set? And then what would it look like to specify those things? When we say mirror, do we mean like mirror from the compiler, or mirror from, or some abstract notion of mirror? I think the latter. I don't know. Those are some of the questions I think might be good to focus on.
Yeah, I would like to pick up that ball. The reason why this focus on mirror also came up a little on why we focused on that a bit was also the second question that we had to many folks is like, do you need a stable mirror, or do you just need to know what's there? And the answer was made very dominantly in the we need to know what's there. So everyone needs to figure out what the current version of the Rust compiler patch after patch does. Particularly the one group that we spoke to was the group that we were talking to about Galois, who produced the Crux tool that you can find online that does precisely this kind of analysis if you want to look at. So that was an interesting part that a lot of people that we interviewed were actually not into, well, certainly some taking the speed out, but more on actual gathered and committed knowledge rather than strict stability. And
can you clarify what I'm not sure I understand what the distinction you're drawing.
Well, the strict stability would be we specify mirror and then it never changes. Rather than there's still the option to change as long as we document the changes. Is the simpler goal and the easier to reach goal. But still gives people who are interested in doing that kind of work the effort there. And this is basically the conversation we want to have is we believe it's now time to bring these concerns into the language evolution and think about them, and also bring the hands to actually do that. We think it would be a huge boost to the language if that were a concern that was handled to a certain extent at the core. Sure, if every validation approach needs to be implemented by the Rust project, but saying like mirror is the basis for a lot of the verification. For that reason, we can use that as a platform. Same goes for things like Chalk and Polonius and all the components we already have. How do they fit into that story? And that's the conversation that we would like to start.
Yeah, from our view, we've been looking for what is the normative definition that we can do compiler assurance on. Starting from the Rust source language seems much more complex than trying to assure from MIRI on down. And trying to provide assurance the other way, is the language well defined? Is it well defined how the language compiles? Mirror seems like a good middle ground between the front end. So a contract between the front end and MIRI, or mirror, and a contract between mirror and the back end. And this gives us a funnel for making assurance practical. Is that a good summary, the basic thought there, Florian?
Yes.
I would agree with that also. So having work on building some of these tools, Mirror is a great representation to go from. It sort of has the right level of information, but we're very worried about making sure that we're sound and that we stay sound. I'm more than willing to invest engineering time in keeping up with changes, but I want to make sure I'm actually doing that, right? So it would be great to know sort of as Mirror evolves, to know that we are actually keeping up with the semantics and that we don't have stuff where, our tool still works, but the semantics have changed subtly and we're now giving some unsigned results.
That
But
makes a
obviously,
huge.
yeah. Good.
I was just going to say that makes a huge amount of sense, and that seems substantially more reasonable in terms of following as it evolves rather than expecting it to stop or slow its evolution. Related to that, there are a few different ways that mirror could potentially be used, and I'm wondering, it sounds like you're primarily interested in consuming mirror that was generated by the Rust compiler and analyzing it in various ways. Do you have, or are you driving towards any interest in producing mirror and expecting it to be consumed by the Rust compiler when it wasn't produced by the Rust compiler, which would be a substantially larger ask and more complex surface area? Or are you just looking for a standard that allows you to safely and versionedly consume it in order to do analysis and similar?
Yeah, I wanted to, in the research
sorry.
that we had, I'll jump in. I because we've had some conversations with folks about this. I'd say they're two separate goals, and I'd say consuming the serialized output is probably the more important of the two goals, of being able to say, you know, these subset of compiler versions are using Mir 12 and this one's using Mir 13, and that way any tool that's consuming that can say, maybe I support multiple, but I can at least verify that the one that I'm consuming matches with my assumptions and things like that, even if it's a totally breaking change every revision. I'd say from the opposite side of that, there may be some interest in going the other way. If there was a desire to have multiple front ends and multiple back ends that were interchangeable, because right now Mir is pretty close to the level that we feed to Crane Lift or LLVM, and it seems to also be the pivot point of backends. So there could be a desire to feed the Rust current front end into a different non-LLVM backend, and then maybe at some point in the future having a different Rust front end that could be fed into a compatible Rust backend that are speaking the same version of that. But I would say the initial, more primary pressing goal would probably be having a versioned, serialized output version of Mir. Not even necessarily Mir exactly, but a serialized Mir format that has a version number associated with it that follows a certain set of principles that can be encoded into that specific version of serialized Mir is what we've talked about as one possible option in the past.
Okay. That seems very reasonable. The reason I was asking that was concretely that consuming what Rust is producing and versioning it reasonably seems like a substantially smaller ask and easier for us to potentially accommodate. Being able to produce Mir that might exercise surface area that the Rust compiler itself does not produce. Mir is a kind of, while I realize it's an easier surface area to work with for formal specification, it is a lower level surface area than the Rust language, such that if I would expect pieces of Mir that are not actually emitted by Rust-C to be less well exercised, which suggests that being able to generate it may potentially be more problematic. So if that were the ask, I think we'd want to have a much more detailed and careful specification of the interface for the purposes of what works and does not work. But that's not an issue if we're primarily talking about consuming the output of Rust-C. So that was all I was trying to find out. Thanks.
Yep, I think aspirationally, that would be helpful. I know there are, and this is just a very small sort of sample set, but there are folks who are interested in using languages like Coq, for instance, or F-star to compile down to Rust. And one of the points that I've heard on a couple of occasions now is that Rust actually kind of gets in the way because there's, there's quite a lot of like they want the memory safety and they want the ecosystem of Rust, but they don't necessarily want Rust as the language front end to actually do that transcompilation. They would much rather target Mirror because it has a lot less in the way. This is
interesting. So less of the concern of let's compile.
I just wanted to box this. I think it's good,
Yeah.
but I think it's also a tangent. it seems
But
like
how about-
we want to start with
Daniel was
taking mirror,
raising-
right?
Can,
Yeah, go
can we
ahead,
just
Daniel.
quickly-
A foot there. So 2 points. One, actually, so to begin with, we're mostly interested in consuming mirror and then translating it into sort of the input for the kinds of model checking that we do. But one phase of that is that we're likely to want to do some mirror-to-mirror transformations, right? For example, to add ghost state to allow us to track properties that we're looking for. And so those often make the most sense as mirror-to-mirror translations. So having a nice way to do that kind of transformation would be nice. The other thing, which I just want to push on the stack, is a concern that I have is about the fidelity of mirror to the original Rust. In particular, if we're looking for things like undefined behavior, it's possible that there may be UV that existed in the original Rust, but where the compiler gave some implementation defined semantics to it. And so if there's a way to say, like, I really want, like, don't try to do that at all. Try as much as possible to maintain the existence of undefined behavior so that we can catch that. We don't want to be reliant on the compiler sort of getting lucky in code working.
Real quick, I also want to echo the mirror-to-mirror transforms for the safety critical space as well, because things like verifiable optimizations and things like that, if we have sort of a language spec to do that, optimizations are a tricky thing in a lot of the higher safety critical areas, and having an easier way to do optimizations on a mirror-to-mirror level could also be an interesting thing. I don't want to get too deep into it, but I wanted to echo that point from Daniel that mirror-to-mirror transforms are also likely fairly interesting.
So that seems like something that the compiler, like sort of an engine, like it's sort of an engineering effort first and foremost, and less of a spec based effort to me. I think it's definitely something we could enable down the line without a lot of challenge, actually, but a lot of that is going to be tooling the compiler to do it, and not so much that.
Something that it's actually sort of outlined in the document a little bit, sort of like what, if you were to define formal semantics of those translations, then you'd be able to test, right, those transformations and make sure that they're also sound and, you know, they're total and there's no, so there is some benefit of that specification, but I think we specifically point out that lightweight specification, whatever lightweight we decide that lightweight means, would still be helpful. So that people have some understanding of what they can expect, and that so that we can do some lightweight verification of those things. I think that's, again, sort of an aspirational effort, but if you look at projects like ComCert, which, you know, try to be the, you know, we're going to specify all of the optimizations, there's interest there for sure.
Part of why I brought up the compiler there is that I think this is a really good, ultimately this effort is going to be bigger than, it's going to involve different parts of the Rust org, right? And a large part of the practicality of what solving the practical problems of working with mirror is probably going to be involving the compiler team and involving a certain amount of, like, can we define libraries? My hunch is, and I don't want to go too far down that road, but that the best way to do this would be to have a separate crate that defines, like, portable mirror or something, and the compiler has its own copy of mirror, and there's a translation between them, and, you know, that translation gets maintained by people as things change, and, like, the group, I could imagine a group working and developing that, just because if we want to have an interface, we want to be able to know, we want something with more stability and where we have, like, semver on it, right? And I'm not sure if that is going to be one copy or not, but I also think this team isn't the one to make that decision, and so I think we should, like, segregate out some of that and talk a little bit more about what would a spec look like. And one of the questions that was raised here is, or what my biggest concern, honestly, is how do we keep the Lang team abreast of what's happening without requiring us to attend all the meetings? And not just the Lang team really, but I mean, like, the Rust community, the set of people in the community who want to follow along, and who have the time and, you know, knowledge to do so.
Maybe I can tie that a little together. I agree that this is a cross-cutting concern. And basically, to circle back what I said in the beginning, this is why we want to have the conversation on the project or on the project teams to make sure that, especially also the different perspectives on this, there's interest in verified optimizations, both from the safety critical, but also, for example, from the mission critical perspective of Amazon, so that I believe there's a design space there where if you talk to multiple groups, this just becomes better, also from the engineering perspective. Yeah.
But
I see Felix has a
isn't it the
hand
case,
emoji.
though- Isn't it the
Oh.
case, though, that the first thing to do is define what the thing is? Maybe it doesn't need to change significantly to be well defined. The first effort is to write a definition, I think, and then we'll see what changes and have a roadmap for how those changes would roll out. So that's how I would think we would bound the complexity of coordinating, is have a well-defined roadmap.
All right, I'm going to jump in now. I've waited. Yeah, my hand was raised, but this is actually what I'm going to say is sort of related to what you just said. Is that Jack? So I think we've already sort of outlined in previous parts of this dialogue that this story is not just about the mirror in terms of defining the bodies of code inside of Rust functions, but also I think the type system and references to that. And so I wanted to try to, in an effort to at least have some idea of the scope here and how it might blow up or how we can keep it contained. Are there any other static analysis results that you expect to be part of the serialized format you'll need access to? I'm thinking in particular of the borrow checker or the region inference that may or may not be part of the type system that we'll need to define. So I wanted to say up front, an idea up front about whether that's going to have to be part of the format that's going to be included here. Or if you don't know, it might be an unknown. That's fine too. I just wanted to first say it out loud.
Yep, I have a little bit of context here. And it depends on who you talk to and what their needs are. Some folks are interested in a mirror that is to be borrow checked, just to sort of describe it that way. But then there are some folks who are interested in mere sort of post-borrow checking, post-monomorphization, so that they can consume it effectively after Rust guarantees have been executed and there's some proof of erasure in a way. So I think this what we're primarily looking for in this document is the first or the former.
There's a point in between the two that I want to make sure I also at least make clear here. When you say the mere to be borrow check, that you could interpret that to mean, we wrote our own borrow check. Someone else, a third party, wrote their own borrow checker, and they're going to apply it to the mirror. That is different from having a serialized proof that of what the Rust compiler itself did in its borrow checking and validating that, right? And that's
right.
Space.
This is, I guess, so when you say consumption, right? So consuming meaning this is output from the Rust compiler that we're then going to use for automated reasoning or tools and things like that. Yes, so I think in that case, yes, it would be sort of after borrow checking, after any expansion and transformation, because we do want that proof. But again, I think you will hear different things from different people.
Just to make it, just
In
to
that case, go on, Nico.
Like one very specific thing, I know that the effort at ETH consumed borrow check results, but Felix. So they wanted to get they wanted the connections the borrow checker was making to inform their analysis.
And that can be very useful because one of the things that really absolutely kills the performance of these reasoning tools is having to deal with memory and the heap and aliasing. So anything that we can reuse from any analysis that's been done inside the compiler about aliasing can dramatically improve the scalability And then also can be useful for correctness, right? If we know that the borrow checker assumed that these two things could never alias, and then we can find a path where they did, now we've shown a potential bug. So both directions are useful there.
Okay, so I guess my point is that then it'd be good to at least have some bound on the number of static analyses that you'd want. Either, again, it also can come down to, okay, are you expecting just a statement from the compiler saying I borrow checked this successfully, or like a proof that could be validated, right? And those are different, or just the static analysis results without a so-called proof, and the third-party tool would, if it needed to or wanted to, could attempt to reconstruct those results or validate them themselves. But the point, right, there's a difference there between just taking the borrow checker's output as a given, saying, okay, these are the lifetimes you figured out, I'm not going to worry about validating them, I'm just going to use them as my own tools routine, which is a totally different kind of problem than having a construct, than making the compiler construct a proof that would have to be validated. So I guess I'm just trying to get at the heart of, because I don't expect us in the compiler to be generating a proof anytime soon.
What the Prousty work did, Felix, is it took the output and used it to generate the proofs, if I recall, that, or like used it to generate some of the things that are then fed into the proof checker. And the idea was it also along the way was proving that the borrow checker was sound, because if the proof checker failed to find a proof, like those things ought to make the proof succeed, in short. But it's not that it trusted the borrow checker per se.
Right. Okay, that's a case of like certifying the output, which is yeah, totally cool and great.
I think if we supported, from like a very practical perspective, I think if we exposed something like Polonius with a stable API along with Chalk, we would give kind of everything people might want that we have to give. But
as you've been raising specifications, Nico, there's an interesting tangent there, particularly around the borrow checker and, for example, also around type inference. Particularly if we're talking about enabling third-party implementations of this, or even future implementations of the same concept by ourselves. We've rewritten the borrow checker multiple times. The question is, how much of that needs to be specified? Like, is it specified as a minimal guarantee? A borrow checker for us needs to do at least this. Or do you go for a specification that nails down all the rules? But in that case, would potentially bar future research that might make the borrow checker a lot more convenient. Someone finds yeah. So this is something that needs to be taken under account if we're talking about specification and not verification. Is a specification strategy might block future implementations, or we can find a specification strategy that does not.
So I'm, at least as a user, I'm okay with, again, versioning that, right? You can say, if you're using, mirror version X, you have a borrow checker that will give the following specifications into it. But we're going to bump the major version number in order to change how we do borrow checking.
I think the other thing is, like, we're kind of not there yet in some sense. I think if you take stack borrows, like part of what Ralph was shooting to do with that was to define a kind of base layer of undefined behavior that must under no circumstances happen, right? And then the question is to show that the borrow checker guarantees that behavior doesn't happen, but there's some space. It's a conservative analysis, so there's plenty of space to make it more precise, but you wouldn't change the definition of undefined behavior, just narrowing the envelope, like getting closer and closer.
Right. And I think to everyone's point, like I used the word proof in a maybe less than rigorous way here. In that is if people understand that the borrow checker is sound, because we have evidence either through another project or we've actually performed the verification work, then the overall sort of concept here is improving trust. If you can trust that the borrow checker is in fact doing what it's supposed to do and is conformant to some understanding what conformant means, then we're able to take that and basically move on into the thing that we actually care about. So I don't necessarily think that there's an expectation that the biochecker is producing something that we can then prove in that regard. Like every time it compiles, every time it runs. I don't think that's the expectation here.
So we have 18 minutes left. Maybe we should talk a little bit about next steps. What goes next? I don't know. I would like to hear what people want to do. I think I have some ideas what I think should happen, but
go ahead. So the goal from our side is actually to continue that conversation and bring it somewhere in the open and on project grounds. Also for multiple reasons. First of all, we did a lot of research and we think there's it's a good moment to start that. There's a limelight on Rust, there's industry interest. I think showing that there's interest from Rust in those interests is also good. Starting work earlier always has the advantage of not being rushed the moment people need it next month. Also for all the input that we now had, and also all the input that we can get in a more open design process. And so our preferred outcome of this meeting was actually like find the group that continues this conversation and actually turns that into more tangible roadmaps and things to do.
I think, that seems like a good thing to look for. And I guess what I would be interested in from my perspective is the very first thing would be kind of this roadmap, like some kind of document that sketches in more detail what are the things to be produced and what are some of the concerns, and not all the way down the line, just what are the first one or two things we want to actually do. That seems sufficient. And I guess I'm a little bit curious to dive, not live, but to talk about some of the more complex topics like unsafe code and rules around it, and are those things in scope or out of scope for those first few documents, and when do we think they'll become important? Because I'm trying to figure out how this interact, for example, how this effort interacts with unsafe code guidelines. In my head, they're very close, but I could see a world where they're not, if you were trying to exclude unsafe code, for example. But
I'd say at least from the safety critical side, or especially the less rigorous levels of safety critical software, the nice thing is there's a little less absolutism in that it doesn't all have to be formally proven, and there can be escape hatches where we say this is not handled or this requires a human to do manual review, and we can provide a checklist like the unsafe code guidelines where there is a bit of an escape hatch where we say, okay, for all of safe Rust, you're good. And then we do require those kind of things. So I think there are a lot of things that would make sense to start collecting under a similar umbrella, whether this is increasing trust for things like defining unsafe code, for defining certain things like that, or at least exploring what is and isn't covered, and better kind of stating the guarantees of what are and aren't covered, and where those fall on the roadmap, so that people who are maybe interested in that can either chime in and help prioritize that with hands or funding and things like that, or if not, collecting these kind of priorities with people inside and outside of the compiler of either things that are important and not being done that need funding and hands and things like that, and to be sort of a collection point of taking a couple things that are being done in different places, whether it's ETH Zurich or within Amazon or within Ferris or within other research organizations or the compiler itself, and figuring out how these do sort of fit together. So there is a kind of a home and a marching place for this. So I think definitely having a home for this and finding what would be relevant and collaborative on this, and what would be excluded or we think should be excluded today until someone brings new information, I think definitely makes a lot of sense here. Because I think there are parallel efforts of folks trying to either improve the trustability of Rust or working on certain aspects of that. And some of those are disjointed efforts and some of those are done in private. And I think having sort of a beacon inside of the project is going to be helpful in that regard from my position.
If I could piggyback on a comment that was made a minute ago about how much the compiler is going to help people manually verify things. There are different markets with different approaches to verification. So in automotive, for instance, there's a huge body of code, and manual inspection of the binary output isn't practical. So you see in standards like ISO 26262, where you're encouraged to trust the compiler, and compiler certifications are important to automate that process. In other standard industries like aerospace, DO178 certification for software, there's actually a substandard, DO330, I believe it is, that makes it pretty clear you're not really allowed to trust automated tools. And what you want from your automated tools is enough diagnostic information that lets you manually verify that the tool did the thing you think it was going to do, but that check is manual. So in DO178, we don't actually trust our compiler. We have tools in our compiler that lets that verification process be done manually to see how that translation from source to binary happens. And of course, any point where the compiler introduces non-syntactic code, things like, say, C++ exception handling, for instance, lots of code happening there, that you can then identify it, manually verify it as what you think it is, and then trust the binary. So another way to look at the problem.
I think there's also an interesting discussion to be had about the higher you go on these kinds of trust levels, how much can the open source project carry and how much not. Just to be clear, that will definitely be an open discussion to always decide. So that's why we're, after thinking a lot about it, took that approach of let's think of what we can provide as a platform for these efforts. That also, maybe to cover my last point there, we can maybe also reuse to make development of Rust easier. Particularly, I was thinking about when we think about Chalk as a formalization of our type system, we can also use Chalk to prototype extensions of the type system before we actually build it into the compiler full, if you got that factored out. So we do not only need to think about this as an additional load, but maybe a different design.
So it seems like the next step is to create the charter for like a project group, right? Is that would be the obvious shape from my view. And I think we'll want to, like, that charter will inform a little bit who, like we said, it's cross-cutting already, who else we loop in and for what and when, right? But
from my perspective, it would make sense to, if we talk about a group that wants to pick this ball up and start walking with it, then to also circle around all the other groups and collect their feedback and maybe their efforts and their needs.
Yeah, this was sort of what I was imagining, was that we would start drafting, or we being some subset of people here, I don't know which one it is, drafting what we think is the right thing, but then taking it to get feedback on, is that the right thing? Is it actually something we want to do? I'm just wondering a little bit, my other rule of thumb that I've been using lately is don't make a group until the group's already active. And along those lines, because you know, for the obvious reason that sometimes it never works out. I'm wondering, what can we do? Like, to some extent, that charter is an example of work that can be done before the group. Like, the act of creating it is sort of defining the group, but maybe there are other things. I don't know. I would be a bit wary of having like a spec for Mir that lives outside the Rust org. I don't think that's a great universe.
Right.
But on the other hand, I'm not, like, there could be worse things than a good collaboration that's not official until it gets blessed, as long as it's really good. But
Yep, I think like there's been there's also like a lot of thought into this that hasn't been put on the document that we've sent, just because, again, I think there's a lot of things that are in scope and a lot of things that we don't think are, but we can definitely carry that conversation, into a group where we can figure out exactly what is and what isn't in scope, and then figure out like what we need to pull in and who we need to pull in to make that sort of initial iteration off the ground. But I think we have enough information to get that ball rolling pretty hard, and if we need to, we probably should, right? Because I think there is a lot of industrial interest. Obviously, there's a lot of industrial interest here. Yeah, that initial group, people on the call, I think we can work together to get a charter together fairly quickly, and then go from there.
Sabri, are you volunteering to be a contact point?
I will absolutely
People who have interest.
Yes, if you have, and I think I'm on the invite for the. Maybe I'm not, but I'll. Yes, I'll definitely be the point of contact for that. For anyone who has interest in this, and who wants to sort of like work on those initial priorities.
I just want to make expectations clear, like to the extent that I think we're still discussing a hypothetical future official Rust endeavor at this point. It's not like there's no decisions being made right now or anything like that. I feel positive about it, but I think the act of creating this charter and figuring out who we need to talk to and so on seems like a good thing to just clarify. But
yeah, I totally agree with that. I think the first goal of such an effort should be defining what the actual effort from the perspective of the bus project is, and that discussion needs to happen in the scope of the bus project. So yeah, that's why the document looks a lot like there's a couple of Rust suggestions, because the actual commitment needs to come from somewhere else. Thanks.
all right, well, if people don't have Sabri's email, can contact me and I'll give it to you. But I guess let's start by just encouraging folks who want to follow up to get in touch with Sabri, and we'll go from there. Thanks, everybody.
Bye, everyone.
All right.
Thank you.
Thanks.
Bye. Thank you. Thank you all for your time.